When your Chrysler, Dodge, Jeep, or Ram vehicle starts having transmission problems, many shops will immediately recommend a complete transmission rebuild. But is this expensive solution always necessary? Today, we're focusing specifically on two common transmissions found in modern Chrysler vehicles, the 845RE and the 8HP70. These are sophisticated 8-speed automatic transmissions that power millions of vehicles on the road. Here's the problem. When these transmissions develop issues, many shops automatically recommend a complete rebuild, costing $4,000 to $6,000. However, the actual problem might be much more specific and less expensive to fix. The key difference is accurate diagnosis. Instead of assuming the entire transmission needs rebuilding, experienced technicians can identify the specific component causing the problem, whether it's a valve body issue, solenoid failure, or clutch problem. This is where Transmax Transmission makes the difference. With advanced diagnostic equipment and experienced technicians, they can pinpoint the exact problem with your 845RE or 8HP70 transmission, potentially saving you thousands of dollars in unnecessary work. In the following sections, we'll explore the specific components of these transmissions, common failure points, and how proper diagnosis can identify the real problem. You'll learn why a full rebuild isn't always the answer, and how to make informed decisions about your transmission repair. The 845RE and 8HP70 transmissions belong to the renowned ZF 8-speed transmission family, representing some of the most advanced automatic transmissions in modern vehicles. These transmissions are marvels of engineering complexity, featuring intricate internal components that work together to provide smooth, efficient power delivery across 8 forward gears. The 845RE is Chrysler's licensed version of the ZF 8HP transmission, while the 8HP70 represents the original ZF designation. Both share the same fundamental architecture and engineering principles. While these transmissions are generally reliable and represent advanced automotive technology, they are prone to specific issues, particularly when subjected to the increased stress found in trucks, SUVs, and performance vehicles. The increased stress in trucks, SUVs, and performance vehicles comes from higher torque demands, heavier loads, and more aggressive driving conditions. These factors can accelerate wear on specific transmission components. Understanding this transmission family's complexity and stress vulnerabilities is crucial for proper diagnosis and repair. Rather than assuming a complete rebuild is necessary, targeted component analysis can often identify specific failure points. The valve body is one of the most critical and complex components in modern transmissions, serving as the hydraulic control center that orchestrates every gear change. Located within the transmission case, the valve body contains intricate networks of passages, valves, and chambers that direct pressurized transmission fluid to the appropriate clutches and bands. The valve body's primary function is to act as the transmission's brain, receiving electronic signals and converting them into precise hydraulic actions that engage the correct gear ratio. In the ZF 8-speed transmission family, the valve body must precisely control 8 different forward gears, making it significantly more complex than traditional 4- or 6-speed units. This complexity creates multiple potential failure points. The valve body contains numerous small valves, springs, and sealing surfaces that must work in perfect harmony. Each of these 8 gears requires the valve body to direct fluid to specific clutch packs and bands with exact timing and pressure. Any deviation can cause shifting problems or component damage. The most common valve body failures occur at 3 critical locations: the pressure relief valve, end plugs, and priming valve. These areas are particularly susceptible to cross leaks. Cross leaks at these locations allow transmission fluid to flow where it shouldn't, causing incorrect pressure distribution and erratic shifting behavior. When these sealing surfaces wear or become damaged, they create unwanted fluid pathways that disrupt the precise hydraulic control needed for smooth transmission operation. Understanding these valve body vulnerabilities is crucial for proper diagnosis. Rather than assuming a complete rebuild is necessary, identifying specific valve body issues can often lead to more targeted and cost-effective repairs. Solenoids are critical electronic components in modern transmissions that control hydraulic fluid flow to engage different gears. When these components fail, they can cause significant shifting problems and transmission malfunctions. A transmission solenoid is essentially an electronic valve that opens and closes to control the flow of hydraulic fluid. These solenoids receive electrical signals from the transmission control module and respond by directing fluid to specific clutches and bands. This technical diagram shows the internal components of a solenoid valve. Key parts include the electromagnetic coil, the movable core, O-ring seals, and the valve seat. When electricity flows through the coil, it creates a magnetic field that moves the core, opening or closing the valve. However, solenoids are prone to several types of failures that can severely impact transmission performance. The most common issues involve O-ring deterioration, contaminated fluid, and heat-related problems. O-ring seals are particularly vulnerable to failure. These rubber seals are constantly exposed to high pressure, temperature fluctuations, and aggressive transmission fluids. When they crack or tear, they allow fluid to leak between chambers, causing improper solenoid operation. The second major issue affecting solenoids is contaminated transmission fluid. Dirty oil contains particles and debris that can interfere with solenoid operation. This image shows a transmission component sitting in contaminated fluid. When transmission oil becomes dirty with metal particles, clutch material, and other debris, it can clog the tiny passages within solenoids, preventing them from operating smoothly and accurately. High operating temperatures present another significant challenge for solenoid reliability. Excessive heat can cause multiple types of failures. High temperatures are particularly damaging to solenoids. Heat accelerates the breakdown of O-ring materials, changes the electrical properties of solenoid coils, and causes thermal expansion that affects the precise tolerances needed for proper operation. When solenoids fail due to these issues, the results are immediately noticeable to drivers. The transmission may shift harshly, delay engagement, or even enter protective limp mode to prevent further damage. Understanding solenoid issues is crucial for proper transmission diagnosis. Rather than immediately recommending a full rebuild, experienced technicians can often identify and replace specific failed solenoids, saving both time and money while restoring proper transmission operation. The Mechatronic system, also known as the Transmission Control Module or TCM, is the brain of modern automatic transmissions. This sophisticated unit represents the marriage of electronic precision and hydraulic power. Unlike older transmissions that relied purely on mechanical and hydraulic controls, the Mechatronic system integrates electronic sensors, processors, and solenoids with traditional hydraulic valves and passages. Here we can see an actual valve body with its integrated electronic components. Notice the complex arrangement of hydraulic passages combined with the black electrical connector containing numerous pins for electronic control. The Mechatronic system continuously monitors vehicle speed, engine load, throttle position, and transmission temperature to determine the optimal shift points and shift quality for any driving condition. However, the Mechatronic system is vulnerable to two primary failure modes: excessive heat and contaminated transmission fluid. High temperatures can damage the electronic components, while dirty fluid can clog the precise hydraulic passages. When temperatures exceed normal operating ranges, the delicate electronic circuits within the Mechatronic unit begin to degrade, leading to erratic shift patterns, delayed engagement, and eventually complete failure of the transmission control system. Understanding the Mechatronic system is crucial for proper transmission diagnosis. Rather than assuming a complete rebuild is necessary, identifying whether the issue lies in the electronic control, hydraulic operation, or both can lead to more targeted and cost-effective repairs. In the ZF 8-speed transmission family, 3 specific clutches are particularly prone to failure. Understanding these failure points helps diagnose problems more accurately than assuming a full rebuild is needed. This cutaway view shows the complex internal structure of a ZF 8-speed transmission. Within this system, the E, A, and D clutches are critical components that control specific gear ranges. The E clutch is particularly vulnerable to oil deprivation. When transmission fluid doesn't reach this clutch adequately, it causes premature wear. Additionally, the clutch hub design is inherently weak and prone to failure under normal operating conditions. The A clutch has a critical weakness in its backing plate design. Under high hydraulic pressure, this plate flexes, which disrupts the clutch's ability to maintain proper engagement. This manifests as flutter or slipping in 7th and 8th gears, particularly noticeable during highway driving. The D-clutch is another common failure point, especially affecting the transmission's ability to operate in higher gears. When this clutch fails, drivers typically experience problems with 6th, 7th, and 8th gear engagement, often caused by excessive heat and hydraulic pressure stress over time. Understanding these specific clutch failure points is crucial for accurate diagnosis. Rather than automatically recommending a full transmission rebuild, experienced technicians can often identify which specific clutch is causing the problem and replace only that component, saving both time and money. The torque converter is a critical component that transfers power from the engine to the transmission using hydraulic fluid. However, original equipment manufacturer assemblies have several known weaknesses. This exploded diagram shows the complex internal structure of a torque converter. Each component must work in perfect harmony, but several areas are prone to failure in original equipment assemblies. The impeller hub is the most critical failure point in OEM torque converter assemblies. This component connects the engine's flywheel to the torque converter and experiences tremendous stress during operation. Here we see a real example of impeller hub failure. Notice the stress fractures and material fatigue. This type of damage typically occurs when the hub cannot handle the torque loads, especially in heavier vehicles. OEM torque converter assemblies are particularly vulnerable in heavier vehicles and high torque applications. The increased stress from vehicle weight and engine power can quickly overwhelm the impeller hub's design limitations, leading to premature failure. Understanding these weaknesses helps explain why many transmission problems may actually originate from torque converter failure rather than requiring a complete transmission rebuild. Transmission fluid is the lifeblood of your transmission system. Understanding its critical role can save you thousands in unnecessary repairs. Modern automatic transmissions are incredibly complex machines with hundreds of precision components. Each part must work in perfect harmony to deliver smooth shifting and reliable performance. Transmission fluid serves 3 critical functions that keep this complex system operating properly. First, transmission fluid provides lubrication, creating a protective film between moving metal parts to prevent wear and damage. Second, it provides cooling by carrying away the tremendous heat generated by friction and hydraulic operation throughout the transmission. Third, transmission fluid acts as a cleaning agent, suspending wear particles and debris so they can be filtered out, keeping internal components clean. The transmission filter plays a crucial role in this cleaning process, trapping contaminants before they can damage sensitive components. Here we can see a transmission filter inside the transmission pan. This filter removes metal particles, debris, and other contaminants from the fluid before it circulates back through the system. Over time, transmission fluid degrades and becomes contaminated. The color and condition of the fluid tells us a lot about the transmission's health. This chart shows how transmission fluid changes color as it degrades. Fresh fluid is bright red, but as it ages and becomes contaminated, it turns darker. Dark brown or black fluid indicates severe problems and potential transmission damage. Regular transmission fluid and filter changes are essential preventive maintenance. Following the manufacturer's service schedule can prevent most transmission problems and extend the life of your transmission significantly. The transmission repair industry is experiencing a significant shift in approach. Rather than automatically recommending expensive full rebuilds, modern shops are embracing accurate diagnostics to identify the exact source of problems. Let's compare the traditional approach with the modern diagnostic method. The old way often jumped straight to recommending a complete rebuild without thorough investigation. The new approach prioritizes comprehensive diagnostic testing first. This allows technicians to identify the specific component causing the problem, leading to more targeted and cost-effective repairs. Modern diagnostic equipment plays a crucial role in this new approach. Advanced tools can communicate directly with the transmission's electronic systems to identify specific fault codes and performance issues. The diagnostic process involves multiple steps. OBD2 connectors read fault codes, sensors monitor real-time performance, and electronic control units provide detailed analysis. This comprehensive approach leads to precise problem identification. This diagnostic approach delivers significant financial benefits. Let's examine a real-world cost comparison between traditional and modern approaches. Accurate diagnostics provide multiple benefits: significantly reduced repair costs, faster turnaround times, increased customer confidence, and most importantly, prevention of unnecessary work that doesn't address the actual problem. In practice, skilled technicians use sophisticated equipment to perform these diagnostics. Modern transmission shops invest in advanced tools and training to provide accurate problem identification. The shift towards accurate diagnostics represents a fundamental improvement in transmission repair. By identifying the exact problem first, shops can provide more effective, economical solutions that truly address the customer's needs. The transmission repair industry is shifting away from automatic full rebuilds toward a more targeted, component-level repair approach. This method focuses on identifying and replacing only the specific faulty components rather than rebuilding the entire transmission. The traditional approach involves replacing or rebuilding the entire transmission unit, which can be costly and time-consuming. The modern, component-level approach targets only the specific failing parts. Let's examine the three main components that are commonly repaired individually: the valve body, solenoids, and clutch assemblies. Each of these can often be repaired or replaced without touching the rest of the transmission. The valve body is the hydraulic control center of the transmission. When it develops cross leaks or valve sticking, it can often be remanufactured with upgraded components, costing approximately 60% less than a full transmission rebuild. Clutch assemblies, including the A, D, and E clutches, can be individually replaced when they fail. This image shows a complete clutch pack assembly, and here we can see the dramatic difference between worn and new clutch plates. Solenoids and internal components like this machined valve body section can be individually serviced. Solenoid O-rings can be replaced, internal passages cleaned, and specific valves rebuilt without disassembling the entire transmission. Component-level repair offers significant advantages. It's 50 to 70% less expensive than full rebuilds, provides faster turnaround times of just 2 to 3 days, targets only the actual problem areas, and reduces risk by disturbing fewer transmission components. This targeted approach represents the future of transmission repair, offering customers more affordable and efficient solutions while maintaining the same level of reliability as traditional full rebuilds. The Transmission Control Module, or TCM, is essentially the computer brain that controls your transmission's operation. Many transmission problems that seem mechanical can actually be resolved through software updates to this electronic control unit. Software updates work by downloading new programming instructions to the TCM. These updates can modify shift timing, pressure control, and diagnostic parameters without touching any physical components. Software updates can resolve many common transmission symptoms without any physical repairs. These include harsh shifting, incorrect gear selection, poor shift timing, diagnostic error codes, and problems with the transmission's adaptive learning system. The advantages of software updates are significant compared to hardware replacement. Updates are quick to install, cost-effective, require no vehicle downtime, and can even be reversed if needed. This makes them an ideal first step in transmission diagnostics. Here's a real example: a vehicle experiencing harsh shifting and error codes. Instead of rebuilding the transmission, a simple software update corrected the shift timing and pressure parameters, completely resolving the issues at a fraction of the cost. The key takeaway is that software updates should always be considered as the first diagnostic step before moving to expensive hardware replacements. Many transmission problems that appear mechanical are actually software-related and can be resolved quickly and affordably. When transmission manufacturers design components, they often balance cost, weight, and durability. However, some original equipment parts have known weaknesses that can lead to recurring failures. The aftermarket transmission industry has identified these weak points and developed upgraded replacement parts that address these specific failure modes. One of the most significant examples is the Sonax heavy-duty A-clutch backing plate. The original equipment A-clutch backing plate in ZF 8-speed transmissions has a tendency to flex under high pressure. This flexing causes inconsistent clutch engagement, leading to gear flutter, particularly in 7th and 8th gears. The Sonax solution uses a heavier-duty design with increased material thickness. Beyond the A-clutch backing plate, upgraded parts are available for many other known weak points in modern transmissions. These include improved valve body components, enhanced solenoids, and reinforced torque converter assemblies. The key advantage of using upgraded parts is prevention rather than reaction. Instead of waiting for a component to fail and then replacing it with the same weak OEM part, upgraded components address the root cause of the failure. When transmission shops use upgraded parts during repairs, they can offer customers improved reliability and often provide extended warranties on their work, knowing that the weak points have been addressed with superior components. The A-clutch represents one of the most documented weak points in both the ZF8 HP70 and Chrysler 845RE transmissions. Understanding this specific failure can save thousands in unnecessary rebuild costs. In these complex 8-speed transmissions, the A-clutch plays a critical role in engaging higher gears, particularly 7th and 8th gear operations. The primary failure occurs in the A-clutch backing plate. Under high hydraulic pressure, the original equipment backing plate flexes and distorts, leading to inconsistent clutch engagement. This flexing causes erratic shifting, particularly flutter in 7th and 8th gears, and can eventually lead to complete clutch failure, requiring expensive transmission work. Sonax, a leading transmission parts manufacturer, has engineered a heavy-duty backing plate specifically designed to eliminate this failure point. By replacing just the A-clutch backing plate with the Sonax heavy-duty version, transmission shops can address this specific failure point for a fraction of the cost of a complete rebuild. The Sonax heavy-duty backing plate not only solves the immediate problem, but significantly extends the overall transmission lifespan, making it a smart, preventive maintenance investment. This case study demonstrates how targeted, component-level repairs using upgraded parts can address specific transmission weaknesses more effectively and economically than complete rebuilds. In this case study, we examine one of the most common yet misunderstood problems in modern transmissions: valve body cross leaks, and how remanufactured solutions can restore proper function. Cross leaks occur when hydraulic fluid flows between passages that should remain separate. In a valve body, this means pressurized fluid intended for one circuit leaks into another, disrupting the precise hydraulic control needed for proper shifting. Here we see an actual valve body assembly. This complex component contains dozens of precisely machined passages, valves, and sealing surfaces. Over time, wear and contamination can create unwanted connections between these passages. Cross leaks manifest as various shifting problems that can be mistaken for more serious transmission failures. Cross leaks cause delayed or harsh shifting, incorrect gear engagement, pressure loss in specific hydraulic circuits, and erratic shift timing. These symptoms often lead shops to recommend complete transmission rebuilds when the actual problem is localized to the valve body. Fortunately, remanufactured valve bodies offer a targeted solution that addresses these cross-leak issues without requiring a complete transmission rebuild. This technical diagram shows the internal structure of valve components. Remanufactured valve bodies address cross-leak issues through several key improvements over worn OEM units. Remanufactured valve bodies feature restored sealing surfaces that eliminate cross leaks, upgraded valve components that improve durability, and enhanced flow control that restores proper hydraulic function. The result is restored proper hydraulic control throughout the transmission system. With a remanufactured valve body, hydraulic pressure flows precisely to the intended circuits without cross-contamination. Each shift circuit receives the correct pressure at the right time, restoring smooth and reliable transmission operation without the cost and complexity of a complete rebuild. When your transmission encounters serious problems, your vehicle may enter what's called limp mode. This is a protective feature designed to prevent catastrophic damage to your transmission. Limp mode is essentially your vehicle's emergency response system. When the transmission control module detects a serious problem, it automatically restricts the vehicle's performance to protect the transmission from further damage. When limp mode activates, you'll notice immediate limitations. Your vehicle's speed will be restricted, typically to around 35 to 40 miles per hour, and gear selection will be severely limited, often allowing only basic forward and reverse operation. This protective mode exists for good reason. Let me show you what kind of damage limp mode helps prevent by examining real transmission components that have failed. This image shows the devastating result of a transmission component failure. The twisted metal, debris, and complete destruction you see here represents thousands of dollars in damage that could have been prevented if the vehicle had entered limp mode earlier. Now let's examine the common issues that trigger limp mode activation. Understanding these causes helps explain why immediate attention is so critical. The most common triggers include transmission overheating, low or contaminated fluid, faulty solenoids, valve body malfunctions, and sensor failures. Each of these issues can cause the transmission control module to detect unsafe operating conditions. When your vehicle enters limp mode, it's sending you a critical message that immediate professional attention is required. Ignoring this warning and continuing to drive can result in complete transmission failure and repair costs that far exceed what proper diagnosis and targeted repair would cost. Remember, limp mode is not a malfunction. It's a sophisticated protection system working to save your transmission from catastrophic failure. When it activates, seek professional diagnosis immediately to identify and address the underlying problem before permanent damage occurs. Hard or erratic shifting is one of the most common transmission complaints. When a transmission doesn't shift smoothly between gears, it can indicate several different underlying problems that require proper diagnosis to identify and fix correctly. The first potential cause is faulty sensors. Modern transmissions rely on multiple sensors, including speed sensors, position sensors, and temperature sensors. These sensors provide the transmission control module with critical data needed for proper shift timing and quality. When sensors fail or provide incorrect readings, the transmission control module receives bad data, leading to harsh shifts, delayed engagement, or erratic shifting patterns. A faulty speed sensor, for example, can cause the transmission to shift at the wrong time. The second major cause is solenoid problems. Solenoids are electro-hydraulic valves that control pressure and fluid flow within the transmission. They're responsible for engaging and disengaging clutches and bands during gear changes. Common solenoid issues include worn O-ring seals that cause internal leakage, contamination that affects valve operation, electrical connection problems, and slow response times due to wear or debris. Any of these problems can result in poor shift quality. The third cause is contaminated transmission fluid. Clean transmission fluid is essential for smooth operation, providing lubrication, hydraulic pressure, and heat transfer. Over time, fluid can become contaminated with debris, metal particles, and oxidation products. Contaminated fluid reduces lubrication effectiveness, clogs small passages and orifices, causes valves to stick, and reduces heat transfer capability. All of these effects can lead to harsh, delayed, or erratic shifting as the transmission struggles to operate properly. The fourth major cause is low transmission fluid levels. Proper fluid level is critical for consistent hydraulic pressure and system operation. When fluid levels drop below normal, several problems occur that directly affect shift quality. Low fluid allows air to enter the hydraulic system, causes pump cavitation, creates inconsistent pressure delivery, and leads to overheating. These conditions result in delayed engagement, slipping, harsh shifts, and erratic operation as the transmission cannot maintain proper hydraulic control. The key takeaway is that proper diagnosis is absolutely critical. Each of these causes requires a different repair approach. A faulty sensor needs replacement, solenoid problems may need valve body service, contaminated fluid requires a flush and filter change, and low fluid needs leak repair and refill. Without accurate diagnosis, shops may recommend unnecessary rebuilds when a simpler, more targeted repair would solve the problem. This is why experienced technicians use systematic diagnostic procedures to identify the true root cause before recommending any repair work. Transmission experts have developed specific recommendations for ZF 8-speed transmission rebuilds, particularly regarding the Mechatronic assembly. Understanding these expert guidelines can save both time and money while ensuring reliable repairs. The Mechatronic assembly is a critical component that combines electronic control with hydraulic functions. Located within the transmission case, it serves as the brain that controls all shifting operations and hydraulic pressure management. This assembly contains hundreds of internal components, including solenoids, pressure sensors, electronic circuits, and hydraulic valves. Each component must work in perfect harmony to ensure smooth shifting and optimal transmission performance. The challenge lies in accurately assessing the internal health of these components. Unlike mechanical parts that show visible wear, electronic and hydraulic components can fail internally without external signs of damage. Based on these challenges, transmission experts universally recommend replacing the Mechatronic assembly during any ZF 8-speed transmission rebuild. This recommendation is based on years of field experience and failure analysis. This recommendation applies to all ZF 8-speed variants, including the 845RE and 8HP70 found in Chrysler, Dodge, Jeep, and Ram vehicles. Following this expert guidance ensures reliable transmission performance and prevents costly comebacks. Regular transmission service is the most effective way to prevent costly transmission problems. Expert technicians universally agree that following manufacturer service intervals can extend transmission life by decades. Most manufacturers recommend transmission service every 30,000 to 60,000 miles. This includes fluid changes, filter replacement, and system inspection. Following this schedule prevents 90% of transmission failures. Transmission fluid degrades over time, changing from bright red to dark brown or black. This color chart shows the progression of fluid condition. Fresh fluid provides optimal lubrication and cooling, while degraded fluid can cause serious damage. The transmission filter is a critical component that removes contaminants from the fluid. A new filter costs only $30 to $50, but prevents thousands in repair costs. Clogged filters restrict fluid flow and can cause valve body damage. Regular service protects all internal transmission components. Clean fluid prevents clutch pack burning, valve body scoring, and gear wear. Properly maintained transmissions routinely exceed 200,000 miles of reliable operation. Neglecting transmission service leads to multiple serious problems. Warning lights, overheating, shifting difficulties, fluid leaks, unusual sounds, and slipping are all consequences of dirty transmission fluid. These problems compound quickly and lead to complete transmission failure. The cost comparison is dramatic. Regular transmission service costs $150 to $300 every 30,000 to 60,000 miles. A transmission rebuild costs $3,000 to $5,000. Proper maintenance saves thousands over the vehicle's lifetime. Transmission experts provide these key recommendations. Follow manufacturer intervals religiously, use only specified fluid, replace the filter with every service, check fluid levels monthly, address leaks immediately, and service more frequently in severe driving conditions. Regular transmission service is the single most important factor in transmission longevity. The small investment in preventive maintenance pays enormous dividends in reliability and cost savings over the vehicle's lifetime. When facing transmission problems, shops have several options. However, the complexity of modern 8-speed transmissions means that experience level plays a crucial role in determining the best approach. Modern 8-speed transmissions are incredibly complex machines. They feature 8 forward gears with intricate hydraulic systems, integrated electronic controls, and require precise tolerances that demand specialized knowledge and tools. Shops typically have 3 main options when dealing with transmission problems: rebuilding the existing unit, installing a remanufactured transmission, or using a low-mileage used transmission. Inexperienced shops face significant risks when attempting to rebuild these complex transmissions. These include improper assembly, lack of specialized equipment, missing technical updates, inadequate testing, and higher warranty claims. Experts recommend that inexperienced shops consider remanufactured units or verified low mileage used transmissions rather than attempting complex rebuilds. However, experienced specialists with proper tools and training can successfully rebuild these units when quality control measures are in place. The decision comes down to expertise. Shops with proven F8-speed experience can consider rebuilds with proper quality control. However, shops without this specialized knowledge should choose remanufactured or low-mileage used transmissions to ensure customer satisfaction and avoid costly comebacks. One of the biggest challenges facing vehicle owners with ZF 8-speed transmission problems is finding qualified technicians who truly understand these complex systems. While many dealerships display certification logos and claim expertise, the reality is that not all technicians have received adequate training on the intricate ZF 8-speed transmission systems used in Chrysler, Dodge, Jeep, and Ram vehicles. The ZF 8-speed transmission is incredibly complex, with hundreds of components, sophisticated electronic controls, and intricate hydraulic systems. This level of complexity requires specialized knowledge that goes beyond basic automotive training. When dealership technicians lack proper training, they often default to the most expensive solution, recommending a complete transmission replacement. This can cost vehicle owners thousands of dollars unnecessarily. The solution is to seek out specialized transmission shops with properly trained technicians. These shops invest in ongoing education, advanced diagnostic equipment, and have extensive experience with ZF 8-speed systems. Look for shops with ASE Master Technician certifications and specific ZF transmission training. These credentials indicate a commitment to excellence and ongoing professional development in transmission repair. By choosing a qualified specialist over an inadequately trained dealership technician, you can avoid unnecessary transmission replacements and save thousands of dollars while getting the expert care your vehicle deserves. Transmax Transmission takes a fundamentally different approach to transmission problems. Instead of jumping to expensive rebuild recommendations, they invest in advanced diagnostic tools and systematic analysis to identify the exact source of issues. The foundation of accurate diagnosis begins with advanced diagnostic equipment. Transmax uses state-of-the-art computer diagnostic tools that can read transmission control module data, monitor real-time sensor readings, and perform comprehensive system tests. Diagnostic equipment is only as good as the technicians using it. Transmax employs experienced technicians who are specifically trained on complex 8-speed transmissions, like the 845RE and 8HP70. This specialized knowledge allows them to interpret diagnostic data accurately. Rather than defaulting to full rebuilds, Transmax considers all repair options. They perform component-level analysis to determine if specific parts like valve bodies, solenoids, or individual clutches can be repaired or replaced, potentially saving thousands of dollars. This systematic approach means customers get accurate diagnoses, targeted repairs, and significant cost savings. Transmax's investment in proper diagnostic equipment and technician training ensures that transmission problems are solved correctly the first time, without unnecessary work or expense. Transmax Transmissions' commitment to excellence goes beyond just having skilled technicians. They maintain a rigorous approach to staying current with the rapidly evolving world of transmission technology. Modern transmissions like the ZF 8-speed family rely heavily on software control. Transmax stays current with the latest software updates and calibrations that manufacturers release to address known issues and improve performance. Beyond software, Transmax technicians continuously update their knowledge of repair procedures. As manufacturers discover new failure patterns and develop improved repair techniques, Transmax ensures their team is trained on the latest methods. Proper fluid maintenance is absolutely critical for transmission longevity. Transmax emphasizes this fundamental principle, understanding that many transmission failures can be prevented with proper fluid care and selection. Transmax uses only high-quality transmission fluids that meet or exceed manufacturer specifications. They understand that using the correct fluid type is not just a recommendation, but a critical requirement for proper transmission operation. This commitment to staying current with technology and maintaining proper fluid standards directly translates to better outcomes for customers. Transmissions last longer, perform better, and require fewer repairs when serviced by technicians who stay up to date with the latest knowledge and use quality materials. After examining all the evidence, the conclusion is clear. A full transmission rebuild is not always necessary for 845RE and 8HP70 transmissions. Many problems can be solved more efficiently and cost-effectively. These transmissions are complex systems with hundreds of individual components. While this complexity can seem overwhelming, it also means that problems are often isolated to specific parts rather than the entire system. The financial difference between a full rebuild and targeted component repair can be substantial. A complete rebuild might cost $3,000 to $5,000, while addressing the actual problem could cost just a few hundred to $1,000. Transmax Transmissions' expertise lies in accurate diagnosis and targeted solutions. Instead of automatically recommending the most expensive option, they invest time in finding the real problem and addressing it efficiently. The next time you're told your transmission needs a complete rebuild, remember that proper diagnosis and component-level repairs can often solve the problem while saving you thousands of dollars. Choose expertise over expensive assumptions.